This lesson is characteristics of quadratic functions. Here are two definitions for this section. You're going to look and see 0 of a function, and this is an x value that makes the function equal to 0. So x value is going to be equal to 0. A 0 of a function is the same as the x-intercept of a function. So when you're looking at 0 of a function, you're looking at the x-intercept. You'll also notice axis of symmetry. They'll ask you this, and this is a vertical line that divides a parabola into two symmetrical halves. So here we have three different charts. I want you writing these charts out. I don't want you copying and pasting them. And the first chart here is finding the axis of symmetry by using zeros. So here we have our 1, 0. If a function has 1, 0, you're going to use the x-coordinate of the vertex to find the axis of symmetry. So here we have a vertex. Here's our minimum point, which is our vertex is at 3, 0. Our axis of symmetry is that line that goes straight down the middle of the parabola that is symmetrical to the other side. The axis of symmetry falls at the point here where x equals 3. When we're looking at the second graph here on the chart, we have two zeros that fall, two zeros, because notice the parabola crosses 0 at two different points. So it says two zeros as if a function has two zeros. Use the average of the two zeros to find the axis of symmetry. So what they did is they added, notice our zeros are at -4, 0 and 0, 0. So you added the zeros together and divided by 2. So the axis of symmetry here is going to be -2, because -4 plus 0 is -4, divided by 2 is -2. My third chart here is a formula to help us find the axis of symmetry using the formula provided. So it says, for a quadratic function in the form of y equals ax squared plus bx plus c, the axis of symmetry is the vertical line. So using that y equals ax squared plus bx plus c, to find the axis of symmetry, do x equals -b divided by 2a. Here we have an example, 2x squared plus 4x plus 5. What is my b value? That's 4. Notice it's in blue. My a value is 2, which is in red. So you take your b value, -4 divided by 2 times 2. -4 divided by 4 gives me -1, so my axis of symmetry is going to be 1 here. Last thing we need to think about when we're coming to find the vertex, so this is my second chart, this is my third chart. When we're finding the vertex of a parabola, our first step is to find the x-coordinate of the vertex. Find the axis of symmetry by using zeros or the formula. So here we looked at the zeros, here we looked at the formula with axis of symmetry. Step 2, we then find the corresponding y-coordinate. We're going to substitute the x-coordinate of the vertex into the function, and then we're going to write the vertex as an ordered pair. So all of these things we just looked at in the charts, we're going to do some examples relating to this. Here's our first example. They want us to find the zeros of each quadratic function from the graph. Check your work. So for a, we have y equals -4x squared minus 2. So in order to find my zeros, I'm going to graph this. So you can create even 2, you can create an XY chart. And actually, for this one, they'll provide you the graph. So you don't even need to worry about creating the XY table, because it will provide you the graph. And what you need to find in this graph is if your parabola crosses the x-axis anywhere at 0. And you'll notice that it does not, so this graph does not cross the x-axis, so therefore there are no zeros of this function. And this would be your answer here for A. For b, we have the function of y equals x squared minus 6x plus 9. Here's the graph that represents that quadratic function, our parabola. And what we need to notice here is if there's any zeros connected here. Well, notice my minimum value right here crosses at 0. When we look at the origin 0, 0, that point falls at 3, 0. So the 0 appears to be at the value 3. 3 is my x, 0 is my y. My 0 value is going to be 3. For example 2 here, we're going to find the axis of symmetry of each parabola. We're going to use the vertical line test to help find the axis of symmetry. So notice A here, we have our parabola. Our minimum value falls at the point here, -3, 0. So to find the axis of symmetry, what's going to, notice my minimum value falls right at the axis of symmetry. If I draw a vertical line, example vertical line test is something you can think about. At what point does my axis of symmetry fall at here? Well, it's at the value -3, 0, my minimum point as well. So what I can do here, whoops, is my axis of symmetry is going to be -3, because I can draw my vertical line going straight down the middle of my parabola. Looking at B here, we have another graph. Notice we have a maximum point. And what we can do here is we can determine the axis of symmetry by drawing a line going straight down the center. Whoops, sorry, it's a little crooked. Or think of our zeros. So we have here -2, 0, and we have here 1, 2, 3, 4, 0. And what we can do here is find the average by adding the two zeros together. So -2 plus 4 and dividing that by 2. -2 plus 4 is going to give me 2 divided by 2, which simplifies to 1. And when I drew the vertical line, notice how it does cross here at 1. So my axis of symmetry for B is going to be the value 1. For example 3, they want us to find the axis of symmetry of the graph given the equation y equals 2x squared plus x plus 3. Here we're going to use that axis of symmetry formula, which x equals -b over 2 times a. So we can look at this and say this 2x squared, my 2 is representing my a. I don't have a value here in front of x, so we can call this 1. And that value is going to be my b. And 3 is going to be my c. So now that I've labeled my values with the correct variables, I can set it up using the formula to find my axis of symmetry. So the way we'd set this up is x equals negative, what is my b? 1 over 2 times my a value is 2. So when I simplify this, this is going to be x equals -1 over 2 times 2 is 4. So x is -1/4. So my axis of symmetry for this equation is going to be the value -1/4. Answer. Here they want us to find the vertex of the graph. We have y equals x squared minus 4x minus 10. So there's 3 steps in order to find my vertex. We first need to find the x-coordinate. We can use the axis of symmetry equation to help us do that, -b over 2 times a. We're then going to find the corresponding y-coordinate. So once we find our value for x, we're going to substitute that back into the original equation here to find my y. and then we would write our ordered pairs. So let's set this up with this equation. So we have x equals negative. Here we have a, b, and c. No value in front of x squared, so we think of that as 1. So we have negative 1 over 2 times, I'm sorry, negative b. b is 4. So negative, my value for b is 4. Over 2 times my a, which is 1 here. So my x equals negative 4 over 2, which is going to simplify to be x equals negative 2. One thing I did forget to put in here was a negative sign with the 4 because it is negative. Double negatives, negative and negative becomes positive. So it's actually going to be, my x is going to be a positive 2 value because the negative symbol in front of my 4 here. I found my x. Now let's substitute that 2 in for my equation to find my y. So what I have here is 2 squared, x squared minus 4 times 2 minus 10. 2 squared is 2 times 2, which is 4, minus 4 times 2 is 8, minus 10. And when I simplify this, I'm going to get y equals negative 14. So I've now found my x, I've found my y. Now we need to write my ordered pair, which is going to be the value 2 comma negative 14. So notice all the steps I did here to help solve this. This was step 1, step 2, and step 3. You do need to show all of that when you're doing bookwork for this section.